Look up at the sideboard, please and thank you. Under Thursday, the 21st of February, SWBA. Faith, what does SWBA stand for? Students will be able to, thank you, Faith, use and understand trig functions for right triangles. Trig functions, I thought this was geometry. Yep, we're going to be talking about an introduction to trig functions this chapter a bit here, okay? So this chapter, the second half of the chapter, too bad, so we're going to be talking about trig functions for right triangles, okay? It's just a very much of an introduction, the first kind of layer of those. In the actual trigonometry class, which you guys could, which I think, which some of you are going to take next year, a few of you are probably going to take in a couple years, is going to be more in depth on a lot of these functions. Okay, so we're going to go starting out today, and then we'll get more in depth. Okay, so our trig functions are the sine, cosine, and tangent ratios. So trig functions are really ratios, but then we actually take a function of them. Owen, put it away, thank you. So if we have a right triangle here, what do we know? If we call this one, if this is angle A, we can call this one side A with a lowercase. Now I want it to be lowercase because we have segments as lowercase. And then also we want it to be opposite A to be the A. So what would I call this side? B, lowercase b, right? And what would I call this side? C. And what do we know about C? It's the hypotenuse, the hip hypotenuse, right? Okay. The hip hypotenuse. Yeah. Okay. I suppose. So now, what can we say is true about this leg in terms of angle A? Where is this leg compared to angle A? It's opposite. So we can call it the leg opposite angle A. I want you to write that in. We call it the leg opposite angle A. So what can we call the B? Yeah, we call it B, leg opposite angle B. Owen, we're vanishing. Please fill out your passbook. Okay, so I heard that. What do we call this? B, we can call it the leg opposite angle B. I can just put opposite as OPP, angle B. Okay, leg opposite angle B. Now, what are you saying? C is equal to the hypotenuse, right? Yeah, C is the hypotenuse. Yep. The hip hypotenuse, Okay. So, in addition to this side A, we call the leg opposite A, angle A. We call it the leg adjacent. Adjacent means what? Connected or next to. Leg adjacent, angle C. Let's put it in terms of another one of these two angles. A non-right angle. B. It is adjacent to angle C, but are there two legs adjacent to angle C? Yeah. So if we say leg adjacent to angle C, that might be a little confusing. But how many legs are adjacent to angle B? Only one. Because the other side that's adjacent to angle B, is the hypotenuse. So the only leg adjacent to angle B is this one. So we can be careful in calling it that. And so, yeah. Adjacent means, I heard it? Connected or next to or by. It just means next to it, basically. So this is the leg by or next to angle B. Yeah, you just said C is the same thing. But we don't need to choose a right angle because here's why. How many legs are adjacent to angle B? Only one. Is this a leg? No, only this is the leg. So there's only one leg that's next to or adjacent to angle B. But if we say angle C, how many legs are adjacent to that? Two. So would that be a little confusing? If we say leg adjacent to angle B, that's just saying it's one of the legs, and we're no further than we were before. Whereas if we say leg adjacent to angle B, we know exactly which leg we're talking about. And I could call this one, in addition to the leg opposite angle B, I could call this one very specifically leg adjacent. I can just put ADJ, angle what? A. Because this leg is adjacent to angle A, even though it's adjacent to angle C as well, but angle A, this is the only leg adjacent to that. It's a little more clarifying. Aubrey.
So saying it's adjacent to angle C would be like the equivalent of like pointing in the middle of something and going, the middle of two things and saying, go get me that.
Yeah. Yeah, basically. So she was saying, if I put this piece of paper here, that there, and I say, go get me that, you guys don't know what I'm talking about, do you? You go to the floor. Okay. You guys don't know which thing I'm talking about because it's in the middle of them. That's what she was saying. Okay, does everyone have this down?
I mean, it's not much to get down.
Okay. So yes?
Yeah.
Oh, okay.
She's like,
Gucci
what I
gang.
said.
Oh, okay. Okay. So, Liddy,
No.
is that fire?
Please stop.
Is that so fire you might have a festival on it?
You sound like
Not
my
my
mother.
Is that her? She pretty Liddy? Cash money?
Stop.
Can't stop, won't stop.
Thebomb.com.
I say that all the time.
Thebomb.com. Okay, got all that one.
This makes me want to cry.
Oh, good. Happy to hear it. That's my goals math teacher. Yeah.
I'd just like to inform everybody that Mr. Consul still is in his early 20s, so technically he's like a young person. He's just a teacher, so he's here, and he's just more cheeky.
He's
Soldier
he's
boy,
basically the
But
kid.
technically, he is a young person. He just seems old.
No.
He just seems
I'm in
old.
millennial, you guys are in Generation Z.
But that is generation
Yeah.
Z.
We're
We're
C bro.
hybrid.
Kids that just
But we're also the
genetically
type, the
hybrid.
middle
It's
generation
6'9".
who like isn't like old enough to be considered like a 90s baby, you know?
Not even close.
No,
we're not
yes.
stupid, Josie.
But we're also not in the Tide Pod generation.
No, you guys are
Okay, we are. We are. They are.
No, this age group is the Tide Pod generation.
I know that's not
I'm not saying you guys each did that, but you guys are in that generation. That's 100% your generation. 100% your
Miss Robin
generation.
agrees with me.
Well, so you guys are beating
She's
Josie.
not wrong. That's not my generation, that's hers.
No.
Wow,
So-
that 1 year separation.
We're gonna talk about SOHCAHTOA.
Mamma mia.
SOHCAHTOA.
That sounds like something that you should chant around a fire.
SOHCAHTOA. SOHCAHTOA.
What breed God is this?
So, in order to talk about SOHCAHTOA, we first need to label this right triangle. If we have angle A, we can call this what? The leg what compared to angle A?
B.
The leg what compared to opposite. Thank you. Leg opposite angle A. And this would be what? The leg adjacent angle A. And this is what the hypotenuse is. Always the hypotenuse no matter what.
No.
That's what it is.
What's that?
Okay.
No.
Okay.
That was aggressive. Who said that? Was that Ian? No, that said shut up.
Shut up.
Who's named into the Jew?
Alright.
Whoa.
Sine of A, the function, sine is a function. Sine of angle A, sine of angle A is going to be equal to, it's the same thing as you can abbreviate it as sin A. Now you don't call it sin though, we still call it sine. We still call it sine. We do not call it sin, we do not call it sin, it is not sin, it is sine. Okay? So this is still sine. 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 Ninth.
Seinfeld, not
Why is it
Seinfeld.
not
You-
spelled then like S-I?
Why
now
me
six.
or sad? The answer is
Because
no.
this is a different kind of sine than that.
Did you learn the math today?
So this is the sine function of angle A, and it's abbreviated SIN with the first three letters, but it's still pronounced sine, not sin. If you pronounce it sin, I will correct you every single time. It will get old. I guarantee it.
Bet. No, I'm gonna do
Fine.
it.
I'm gonna do it.
I'm gonna do it.
She
Sin.
was just having a
Sin.
good day.
Sin.
I'm still
Sine.
gonna do that.
I'm going to commit to
of angle A is leg opposite is equal to the leg opposite. Excuse me, let me change that opposite up. Is the leg opposite angle A
Is that like with side?
Over.
There.
the leg, or excuse me, over, excuse me, not leg, mix myself up, hypotenuse, thank you.
Why do you know this?
Wait,
Because
Or
he's
not.
no one. He has a meme page. He's higher in society than you are.
what? Whoa,
Yeah.
She follows me, she follows me.
I like
Those
all these
signs.
memes. They're
Those
really
memes are
cool.
dead
They're so
It's a
funny.
function.
No memes make
So
sense.
just like, hey, just like in Algebra 1, we learned different functions. Okay, you learned like that, there's an absolute value function that looks like a V. There's a quadratic function that looks like a parabola, okay, or it could be over downward. Okay, there's a cubic function that could look like that, or for you guys, that. There's the quartic function, which would also look similar to a parabola. There's all these different functions. Okay, this is another function. It's another function, it's just the same.
Wait, so it already says sine A. So you have to rewrite sine A?
This is the abbreviation though. So yes. Okay, so it's all in terms of this angle here. If we had cosine of A, we can abbreviate it COS, but we do not call it cos. The only time you should ever say cos in here is if you're in the middle of saying my last name, Mr. Kossel. And if you're saying this, that's not my last name, okay?
What is it?
Wouldn't it be what? No, it's pronounced cosine.
What's up?
No, it's pronounced cosine.
Coast.
Cosine.
Oh my gosh, you guys.
No.
Hey, Capri Sun.
No.
Alright.
No. No. No.
You know, I
No.
hope you know that I wouldn't do this to any other teacher.
I know.
You're welcome.
Thanks.
You get the fun side.
Colossal.
Actually, I do it to Mr. Work too.
Hey, thanks.
Mr. Work is like.
Cosine of A is equal to the leg adjacent angle A divided by the hypotenuse, the hip hop hypotenuse.
No, that's not
Oh, he should drop an album.
Hip hop on out with that.
Oh, God.
I don't want to set the
I
scale
can
fire.
say it right.
Okay, I defended you and called you young and
Hashtag free the hip hop hypotenuse.
I've been doing that for 5 years. Yeah. Like red.
Oh no, I was calculating how old you were then.
I feel like you're. I think the first time you said it to your professor, you
I don't
face
want to
flat.
Guys, let's start calculating our
Tangent of angle A.
Tan.
The third function that we're talking about. Tangent of angle A. Girls, thank you. We can abbreviate it TAN. You do not pronounce it tan though. You still pronounce it tangent.
Okay,
We
but
pronounced
why
it
am I
Florida.
still pronouncing it full when I only see 3 letters and those letters also make a word?
Because it's abbreviated. It's like,
Okay, but when I see LOL, I don't say laugh out loud.
okay, but when you see this, we're not going to say adj. We're going to say adjacent.
Adjective.
When you see this, you're not going to say height.
I
You're going to say hypotenuse.
I like you pronounce
That's why I don't
SWBA.
abbreviate those.
Okay, tangent of angle A. Tangent of angle A is equal to the leg opposite angle A divided by or over the leg adjacent to angle A.
That's really confusing. All of this is really
I know, we'll talk about it more.
okay.
You bet, so bad. Okay, so it's all in reference to the angle. If we had a different angle, then it'd be sine of angle B is equal to the leg opposite angle B over the hypotenuse. But because it's A, we take the same angle and we say, okay, it's leg opposite angle A, it's this leg divided by the hypotenuse. Whatever the length of that would be. These are taking the length and dividing these. It's the length of this leg, the length of the hypotenuse, the length of this leg, the length of the hypotenuse, the length of this leg, the length of this leg. Okay, we have these things over here. So, ka, toa. This is going to be our way to remember what these are. This is our way to remember what these are. Okay? SOHCAHTOA. This is an acronym. It stands for Sine. Sine is opposite over hypotenuse.
No, it doesn't. That is why.
That's too bad, it does.
It doesn't help me.
Sine is opposite over hypotenuse. See that SOH? Sine is opposite over hypotenuse. And you might also see it and think this. Sine is opposite over hypotenuse. Is equal. Sine is opposite over hypotenuse. That's what SOHCAHTOA means. When I write it this way, it's a little easier for us to see the SOH in SOHCAHTOA. I think so.
That sounds like so like random
Oh. Take a view.
The ka in SOHCAHTOA is going to be cosine. Cosine is adjacent over hypotenuse.
Not. We only did it like once.
Just
not
because
for,
you're sitting ahead does not mean you need
Yeah,
to
this is huge on ACT actually.
It's like four. It's like
I think that's what
Okay, so cosine is adjacent over hypotenuse, CAH. So, ka, and then we have toa. Kaylee, go ahead and guess it.
Okay,
I want to
How
say
you
it.
aware?
opposite is opposite over adjacent.
Tangent is opposite over adjacent. Very good. Aubrey, do you have all the sound? I doubt it. You don't have any more right now. There's no yeah probably on that one. So I doubt it.
bet.
Nothing to bet.
That's
No, that doesn't work out very well.
That's-
Aubrey's sanity.
Yeah, don't.
I've only lost one bet this year with the students, so
oh yeah,
Wait, what was it?
that they would get every problem on the assignment right. I didn't think they would. Good job.
Who was it?
That's on board.
You
Yeah,
don't
very
important. That's not an okay thing to do.
I bet you my
Because you're the one
your
teaching
paper.
No, I'm not gonna let you kill my pancreas.
It took me 8 hours.
I got it.
Good job, Gage. Step one.
Okay, so I'm gonna randomly say, hey, SOHCAHTOA, and then what does it stand for? Okay, so every now and then it's gonna happen. Heads up, okay?
Sum it up.
So, however you guys remember that, however you guys can remember, SOHCAHTOA is awesome. But SOHCAHTOA, sines opposite over hypotenuse, SOH. Ka, cosines adjacent over hypotenuse. Toa, tangents opposite over adjacent.
Like a 1, 2, go. When we have to say it.
No.
No.
I'm going
Why
parent.
not?
I'm
Maybe like a
going parent.
Okay.
Sin, off, over.
Well, just remember, hey, so when you get to a test, you need to remember these. You can just write down this at the top of your paper, and that can help you. When you get to a test, you can write down that at the top of your paper and say, oh,
Or you could
there's a
just write
break
it down
there,
for us.
there's a break there.
So,
Say sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. Remember it. Okay? What? Good talk. Example 1. Example 1 here. If we find the sine of B, cosine of B, and tangent of B, let's first start with the sine of angle B. Sine of B is going to be equal to, well, what's sine?
Sine is leg opposite.
Sine is
Opposite over.
Opposite over
So it would be
hypotenuse.
B, so we're trying to figure out B.
Yeah.
It would be the
So-
B, you'd change B and A.
Yeah, so what's opposite angle B? 75. The leg opposite angle B, 75. What's the hypotenuse? 85.
Okay, it's always going to
Solve.
be bigger, so it's always going to be.
So, can we reduce this fraction? Yes, let's reduce this fraction.
Wait, we're going to reduce it like this.
leave it as a fraction for now. Okay, cool.
You're gross.
It's not. It's gonna be.
Divided by what?
Oh, I can't do it that way. So it's gonna be.
5.
Okay. And what's this? What's 75 divided by 5?
15.
85 divided by 5.
17.
Can we simplify that anymore?
No.
Sine of b is 15 over 17. I'm going to find cosine b and tangent of b. And then I actually want you to find sine of a, cosine of a, and tangent of a as well.
Wait,
Oh,
what?
chill.
Whoa.
Can you go back to the
Whoa,
last
way too
lecture? I got
fast.
this formula.
Cos
I got
B.
the other stuff in there. Right down there.
What's your other stuff?
Jace?
Real quick.
I want you to do the rest of example 1. Wait, you found what of b, Riley? Sine of b.
I stopped myself on, I would say,
Good. Good job.
I'm on the
I'm not even gonna try to stop.
I'm not even going to try to stop myself from Mr. Cross when I said When you're done with this example, I want you to raise your hand. Okay, when you're done, or if you're having trouble, I want you to raise your hand.
So for the cos,
For what?
for the cos,
For what?
cos,
I don't know what you mean.
The sign.
You don't. Oh, for sine? Sine? You have a sign up here.
cosine,
Cosine?
for the leg adjacent to A, so I think we're gonna be,
Yep.
would be 85. That's,
Is 85 a leg?
that's the leg. That's the leg?
Yep. Because it says leg.
Oh, so it'd be 40.
So you'll never use the same length twice in the same one. So if you're doing cosine, you won't use hypotenuse twice. Just once. Good, Jacob? Yeah. Thank you.
Wait, what would be adjacent to B then?
Okay, B. I'm saying good. I'm Mr. Cross. Okay. So on B, where's the legs? So that's little b. Little c. Okay. So
What's up,
here's
Coulson?
a knee, right?
Mr. Coulson.
Okay. Is this a leg? Is this a leg? Is this a leg? Right. No. These two are. Okay, which one of these two is next to or adjacent to B? So that's.
Yeah.
That's not next to it.
That's stuck up.
This is next to it. So the one adjacent to angle B is. We don't. This leg's adjacent to angle.
What? Okay, and then. So we're talking about angle
Leg
B?
opposite.
Yes. You say B, sine of B, we're talking about the angle. This leg up here. Say angle A, angle A,
Yeah.
angle A, angle A. We're talking about angle B. Sine of angle B. Yes.
Okay, that makes sense. Okay, now your handwriting.
Do you have an answer for me?
In a second. Oh, very good. So I'm trying the 1 for sine of A, cosine of A.
Otherwise, they're too long.
That's A to what? Oh, tangent? Yeah, that's A.
Yeah.
Sure.
Can't surprise me. Alright, you get one strike if you get it
Once
wrong,
you're
I
done,
say
make sure you raise your hand to have it checked. Once you're done, make sure you raise your hand to have it checked.
Alright, here's the rule. Like live or die. If you die, take your pancreas.
Oh. Jokes on him. When he's like 80s or something, they have to cut off his finger.
Correct. Also correct.
They say correct.
When you're done, raise your hand.
Alright.
Gage, did you get it? Go ahead, you want to check too?
Yeah, is everything looking on?
Yes. Yes.
Good.
Yes.
Caroline.
Yes, you do. Otherwise, we're like 10 likes on every comment.
That actually wasn't that hard.
Yeah.
What you just called me?
Friend.
Yeah, right.
It slowly grows.
Time to teach.
Oh, yes.
C.
We did it.
Yeah, really good. Riley, why is your hand still on?
Did we say for our hands?
Yeah, but only until it's checked. Thank you.
Well,
I acknowledge my pancreas. I'm proud.
You have something.
I'm
I
proud.
need my pancreas though.
We'll get back to that.
My fingers as if it's sick, baby.
A little bit.
I need to use air drugs now.
Alright,
When
you
you
wanna
want to
shake
shake the
the
pancreas of the kid that doesn't have a dad.
Hey, Evan, I'm coming over to your house today. Yeah, I'm kidding.
Yes. Perfect.
That's a good one.
I love Kennedy.
Oh, that is-
She needs help on her DNA project.
We don't have to do the DNA.
You changed my.
There's classes, yes. She was like,
I know, I want
you have to do the DNA on there.
Nah, I don't care about me.
Okay, I'm done.
Faith is
I
out
did,
there.
Fuck it,
that's
just
what I
go
was
on.
thinking.
No, that's not.
Faith is right there.
I'm not
So
shaking
I'll
your
be
hand.
showing
I'm
up
not
there. She was beef rub and I was like,
Foreign exchange students.
Okay.
wait, you shouldn't.
I've already had this out here. Good. This is enough for excellent.
Yes.
It was. Okay. So, did everyone have theirs checked? Oh, dang. Okay. So, what was the cosine of angle B?
8 over 17.
What was the tangent of angle B?
15 over 8.
If you would insist. What was for this one? What was the sine of angle A?
8 over 17.
There's more to this.
What was the cosine of angle A?
15 over 17.
What was the tangent of angle A?
8 over 15. Oh, wow.
Do we notice anything about the sine and cosine of angle A compared to the sine and cosine of
They're
angle B?
opposite.
They just switched, didn't they?
Yes.
Okay. Is that going to be a coincidence?
That's
No.
crazy.
No. Let's look at that. Let's look at this. Because angle A, this is a leg opposite angle A, right?
So it's adjacent.
But so it must be adjacent to angle B. So because it's going to be in sine for angle A, it's going to be opposite angle A, so it's going to be in the sine. It's also going to be on the cosine for angle B because it's adjacent to that one. And same thing with this side, because it's opposite angle B and it'll be in its sine. It's also going to be adjacent to angle A and be in its cosine. And what do we notice about the tangents of these two? They're reciprocals of each other, right? They're reciprocals of each other. They're reciprocals, okay? Here's how you say it.
Did you say that word correctly?
No. So, reciprocal. I can't say it wrong correctly.
Yeah, you can.
Okay. So,
It's like saying, it's like saying butter, but saying it like.
Alright. Go to the next page. 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 Okay. What we're gonna do when we use trig ratios, we're gonna circle the angle that is given to you. We're gonna be given an angle to go off of. Okay, we're gonna be given an angle to go off. We're gonna say, hey, go off of this angle. Like that last time we were given to go off of angle B. Then we said go off of angle A. We can call that our reference angle. We can call it our reference angle. Reference means you go off of that. So we're using that angle as our reference point. We say based upon this angle, this leg is opposite. This leg is adjacent. But it's all in terms of that angle. It's relative to that angle. Because at any point the leg can be opposite one angle, but it's adjacent another. And based off of the reference angle, the one we're talking about, that is going to be one thing. Now the angle might be labeled theta at times. It might be labeled theta at times. That's a new symbol for most of us, if not all of us. Theta is a variable we commonly use. We commonly use it as a variable for angles in math. It's commonly used as a variable for angles in math, and usually only for angles. Okay, it's a Greek letter. It's a Greek letter. They're gonna ask.
Yeah.
Yeah.
Greek letter for Z.
Yeah, it's a Greek letter, but in math, it's often used for a variable for angles. Variable specifically for angles.
Kind of like pi, but for angles.
It's kind of like a zero with a. It's kind of like a zero with a line through the middle, not like a slash,
So
but
an
a
A.
line through the middle.
So
So a
like a
slash.
zero
It's like an Easter egg.
That's what I just said.
Oh.
No, there's really not.
It looks
Okay.
like a
It's like an Easter egg.
Yeah.
It looks
Okay.
like a pill.
Now, on these, we're gonna try and get in the habit here.
Yeah.
Quiet back down. We're gonna get in the habit to label the opposite leg, the adjacent leg, and the hypotenuse in each problem, based upon your reference angle. So we're gonna get in the habit of doing that for every problem based upon the reference angle. Now I recommend labeling those in pencil because sometimes we have to do two angles in the same problem, right? Like on that last triangle. On that last triangle, if we would have done that, let's go back real quick. If we would have labeled these in pen and for angle B and said, oh, this is adjacent, this is opposite, would you have gotten frustrated when we had to go to angle A and like cross those out? Probably a lot of you would. So maybe do it in pencil or pen, different color, I suppose.
Why are you doing
Right? True. So we're gonna form the trig ratios as fractions, and then we simplify the fractions if necessary. We're gonna form the trig ratios as fractions and simplify them if necessary.
It's really all that simple.
Now, how we choose a trig ratio, because sometimes we have to choose a trig ratio in order to find the missing side. Because we can use this to find the missing side. Is we'll go off of our angle and we'll label them opposite, adjacent, hypotenuse, like we talked about. And then we look at what we have and what we're given. And we'll look at what we have and what we need. So let's say we have the opposite leg and we need the hypotenuse. Well, in our SOHCAHTOA, opposite hypotenuse, OH, what deals with sine? So we'll choose sine. Adjacent hypotenuse, AH, that deals with cosine, so we'll choose cosine. If we're looking at the opposite leg and the adjacent leg, OA, that deals with tangent, so we'll choose tangent.
buttons for though?
We'll talk about that in a second.
The one that says sin, cos, and tan.
They say what?
Sin, cos, and tan.
Well,
They say what?
Sin, cos, and
They'll say
tan.
all class are.
You wanna? And we can do this after school too.
What?
We can do this after school too.
You know, 5 minutes before
Okay.
the
I have until like 5:30. I have to teach a dance class.
Perfect. No problem.
Mr. also just has to teach Trevor, so. As long as you know.
What was that laugh?
He's thinking about his Mongolian drill.
Ooh, I had Wuhan, just saying.
Yeah, it's real good, isn't it?
Yeah.
Honestly, when you
Wait.
said Mongolian, I thought you were talking
How
about.
old would you play?
We do Asian
No, I
stuff.
take 2 bowls anyways. I get 2 plates.
Yeah. So you got 4 bowls?
Yeah, I
I
got
haven't
one.
been to- I haven't been to
No,
Mongolian.
because you have to take the meat, you got to put that in one bowl, and then you have to take
Yep.
the noodles in a
But
different
it's
bowl.
difficult. Exactly, right? Okay, thank you. Hey,
No,
so
you don't.
Never been.
in order to find missing sides of a right triangle,
Okay.
we're gonna mark the reference angle. So here we have the angle. We can mark it. We can put a circle around it. So here we have a reference angle. We can mark it. Put a circle around it. Label the hypotenuse, opposite, and adjacent sides based on this reference angle. So this is the what? This is the what?
The J.
This is the
I like it.
opposite. Okay? So now we have to circle which two we want to use. Are we going to use the opposite, hypotenuse, and adjacent? Which two are we going to use?
Opposite.
We're going to underline them.
And
And hypotenuse. We're going to use those two because opposite is the side we're looking for, and hypotenuse is the side we're given. Now, which one of our trig ratios deals with opposite and hypotenuse? O and H. Sine. If we look at SOHCAHTOA, Sine deals with the opposite and hypotenuse. So we're going to do sine. So what we're going to say is sine of an angle. What's our angle?
35.
Sine of 35 degrees in parentheses. We're taking the sine of that angle. It's like you take the square root of something, the square root is a function or operation. We're going to take sine of something, and that's equal to the ratio of what over what? X over 14. Very good. The opposite over the hypotenuse. X is the opposite over the hypotenuse of 14. So now we set up this trig ratio, and in order to solve for X, we need to do what with this 14? Times it. Times by 14 on each side, right?
Multiply.
Okay, multiply by 14
Wait, why are we multiplying by 14?
because we need to get X by itself.
What are you doing, -14 and plus?
No, because that would make it negative. We need to multiply by positive 14 to get rid of positive 14. Because if we had this, Josie, if we had like 14 over 1, if we had like 14 over 1,
Wow.
14 over 1 here, what would, let's see, let's bring down that, let's forget. What happened with this 14 over 1 is X over 14? It would simplify to 1 and 1.
Oh, yeah.
So what are we left with on the right side? Just X. On the left side, we cannot multiply this 14 with 35. You can't do that. Just like we can't multiply 14 times the square root of 35, you couldn't multiply those any closer. You cannot multiply these any closer. Same idea? So this is 14 times sine of 35 degrees. And you can just write them next to each other. Now, how we're actually going to figure this out is you would take your calculator. You would take your calculator right now.
14 multiplied
And
by 35.
you would take, you put in 14, you push the sine button, and you put in your angle, 35, you close the parenthesis and you enter.
Cool.
Okay, so that's 8.0.
So, you push 14, 1, 4, then you push your sine button, then it has sine, it has parenthesis, then you put your angle, which is 35, you close your parenthesis, which is right above the 9, and you push enter.
Oh, wow.
8.030070. Is our constant? You need to teach German.
I need to teach what?
German. Your accent is
9.
on key.
What does 9
That's the
mean?
first time I've heard that. So X is approximately, because we don't get an exact answer, right? We've got a lot of decimals.
9.
Okay? X is approximately what?
0.
Let's go to the let's go to the nearest tenth on this one.
8.
8.0. What? Okay, if you got a different number than 8.03, raise your hand now so I can fix it. You're in a different mode.
You're in sicko mode, not natural.
What does your sister look at you?
She doesn't. She moved away. She's in college now.
Not that sister.
She finally did?
You not say sister. I didn't just assume my sibling's gender.
I did. Yeah. I know. We know she's
Not.
She
She chooses.
chooses.
I'm a 76 gender.
78.
I want to pay a blue box.
Why is there 14?
She identifies as a water bottle.
Why?
Hey, who's someone else that's somewhere? Okay. I know what it is. This one.
Everything.
No, I
Zoom in on it. Haha, people without really vision
Alright, I'm Jason. Nice to meet you.
I'm getting them.
So hard.
That's hard enough.
I don't think I did.
People without 20/20 vision.
Nathan did better than me on reading. I cannot get ready. I
Grab one of
don't
those
know.
Yeah, you have a Daniel, that's not a good one, that's a lie. Yeah.
Ooh, that's a great one. Like,
You're right. What's that? $30, man. $30. Oh my gosh.
There's no holes in the air.
Yeah, there's no.
Hey, real quick, I wanna do one more thing before we move on to example 2. Before we move on to example 2, I wanna do one more thing before we move to example 2. I want everybody to find
No.
too bad,
No.
the tangent
Oh my gosh.
of
No.
tangent of 45 degrees rounded to 4 decimal places. Tangent of 45 degrees rounded to 4 decimal places.
Whoa.
Oh wait, still using this triangle?
No, just in general. So you
Oh,
plug it into your calculator.
I'll use this one.
What?
tan
Get.
45.
45.
Try this.
Oh, it's just one.
I got one.
Okay. Let's do cosine of 67 degrees rounded to cosine rounded to 4 decimal places.
How do you round to a 40?
I don't know.
I got one.
No, not this one.
I got
No,
one.
thank you.
This one's
Take
one.
that one. Are you going to the next one?
390.
Really, Aubrey?
Okay.
9.
Gage, what did you get?
9.
I lost.
That's what I got.
Did anybody not get that?
I got 0.39073111.
They got that. Okay, cool.
No.
Did anybody not get this? Rounded to 4 decimal places, cosine of 67 degrees. Faith, did you get that?
Yeah.
Okay.
0.3907.
Or should I call you lost? Okay. I bet lost.
Lost boys, they never win.
I'm
Hi,
fucking.
buddy. Hi,
I'll
Mr.
take
Costa.
yours.
Nice to meet you.
He's a
One over
lost
here, I
boy,
lost.
he never wins.
Okay.
So
So, you might ask the question. Actually, we'll do that on the next one.
Yeah, we'll do it.
Go to. We don't write this in. We don't write this in.
Don't write it.
We don't write this in. It's not on there.
Angle depression.
Because I just want you guys to look up here right now. Guys. Shh. Thank you. Okay. If I am at point A, this is a horizontal point. Pretend it's actually perfectly horizontal, okay? It's straight horizontal. And I look up, that now created an angle of elevation with that. If we're with the,
So
let me do it with,
If I'm at your door and I take it, if I take a, if I'm going down
hey,
the
where are we
hallway
at?
west,
We're nowhere.
if I'm going down the hallway west, okay, and if I take a left into your classroom, would that take like, it'd be the angle of
No.
connection?
So, no. Okay, so, if we're from a straight horizontal line, compared to that, this is an angle of elevation. Only compared to a straight horizontal line, it's considered an angle of elevation. Because it goes up. Think elevating, elevator, you go up. Okay?
when things go right, you go up and you go places.
There we go. Angle of elevation. Okay? Now, depression literally means being down. If you depress something, it's going down. Okay? So if you depress something, it's going down. It doesn't have to be mental illness. It can be a variety of things. Okay? Guys, voices off. Listen up, please. Listen up. Thank you. If you depress something, it means it's literally just going down. So that means an angle of depression compared to a horizontal line would be straight down. Compared to a horizontal line would be down, an angle downward like that. This would be an angle of depression, whereas this would be an angle of elevation. If I turn it like this now, what kind of angle is it? Depression. If I turn it like this, it's an angle of elevation. It's all based upon where the horizontal is and where you're going from there. When it's like this, it's the angle of depression because the horizontal is here and it's going down from there. Angle of elevation, horizontal is here, it's going up from there. So if we have horizontal, anywhere down, it's an angle of depression. Anywhere up is an angle of elevation. We'll use that on some word problems. So heads up.
Oh, this is the angle of depression.
No, what are you doing?
That's what you did.
Example 2. A rope shaped 20 feet from the base of a building goes to the roof and forms an angle of 58 degrees with the ground. The nearest tenth of a foot, how long is the rope?
Can I make that?
Use 3 colors.
No, wait. Are you doing that today?
Oh, that's what it is. Thank you for reminding me.
Dang
Today,
it.
she's having a good day.
No, I gotta get the whole class graded. Then Mr. House can call her up multiple times.
Teamwork. Oh. That could be like. You can't
You have to do that.
Rough.
Oh,
Oh,
that was
shoot.
really fast.
Oh,
That's
Do you
really
do
fast.
your ruler
That's
already?
I need to wipe things down. Hey, you do it?
Hey, so here, what's this side? What is this? This is a.
That's a leg.
This is the.
Leg.
What part of the picture is it, Aubrey? No.
That's
The
a
rope's
Of
not
the
it.
building.
This is a building. Okay. So this is our building. It has windows and windows and windows and windows, and there's a door here. Okay. It's our building.
That's only 20 feet tall. Why is it something like this?
Okay. Hey.
But it says the rope is
Don't
stacked.
judge
The
architecture.
building is
The
fake.
rope
It's
is
just
fake. The rope is what?
Oh.
That's how you pronounce
You
it.
stack a rope.
Okay. The rope is staked 20 feet from the base of the building. Where's the base of the building? Right here?
Yeah.
Yes.
What kind of angle will the base of the building make with the ground?
Right angle.
Oh, probably right angle.
How straight.
And this rope is 20 feet away from the base of the building. So what would this length be? 20 feet. What is this one? What is this side?
Undetermined.
The hip hop hypotenuse, and it's also our rope. It's also our rope. Were we told an angle in this?
No, well, yes.
No, well, yes, we were.
I thought
Maybe.
Is it 58?
58 degrees? What's 58 degrees?
What's the
What about
ground?
the weather?
The rope with the ground or the building with the ground?
Rope.
Rope with the
So
ground.
right here, 58 degrees?
Correct.
See, Daisy?
Just imagine that like a building sitting at 58 degrees.
Okay.
I get the feeling that's gonna
Hey.
be Italy times.
Hey, questions on how this picture was formed?
Ah.
Okay. So, we're looking for the length of the rope, right?
Okay.
So we're looking for what side of the triangle? Very good, the hypotenuse. And we're given what side right now compared to our angle? Adjacent. And we're looking for hypotenuse. Hey, what's our thing? Our acronym to remember? What's our acronym to remember?
Why doesn't the H make a noise?
SOHCAHTOA. Okay. Who can tell me the first 3 letters? Who can tell me the first 3 words of this? Jacob. Okay, shh. Sine is opposite over hypotenuse. Who can do the next one? Aubrey. Nope. Nope. Gage. Cosine is adjacent over hypotenuse. And Josie, last one? Tangent is opposite over adjacent. We have the adjacent and the hypotenuse. Which of these 3 are we going to use? Sine, cosine, or tangent? Cosine.
Why?
How do we know it's cosine? Well, we have the adjacent, A, and we have the hypotenuse, H.
Boom, guys.
So that's what we look for. Because we have the adjacent, we need the hypotenuse from this angle. So we set it up. Cosine of what? Cosine of an angle, what's our angle? 58 degrees is equal to opposite over hypotenuse. What's the opposite?
Opposite.
20.
What's the
No,
hypotenuse?
it's not.
Yes, it is.
That's
Oh,
adjacent.
I said opposite. Adjacent over hypotenuse. Excuse me, I mixed you guys up. Adjacent over hypotenuse. 20 over x.
So that it's gonna be x equals.
So now, mathematically, what would we do to solve for x? Not divided by 20. So currently, where's x at?
Divide by x.
On the bottom.
20.
Stop throwing out answers. Stop throwing out guesses. Stop throwing out guesses. Stop throwing out guesses.
It's not a guess, it's an
Thank you. X is currently in the denominator. Do we want it to be in the denominator? No. So we need to think, how do we get it out of the denominator? Kaylee.
I'm by 120.
Not right now. So we need to get it. We need to get x out of the denominator first. Ian, times both sides by x.
That's weird.
Okay.
You get x
Because
squared.
now we have x times cosine of 58 degrees is equal to 20. Do we have x in the denominator anymore? No, that's good. We wanted to get it out of there.
We know what you can do?
What? Okay. So what operation are x and cosine of 58 degrees doing together? Multiplying. How can we undo that? Dividing. So what can we divide this side by? Well, we need x to be on the top though.
Cosine of 58.
This seems complicated.
This is so bad.
If we divide this side by cosine of 58, do we have to divide this side by cosine of 58 degrees?
Yeah.
What?
Oh, okay.
What's cosine of 58 degrees divided by itself?
No. X.
Nothing.
Just 1, so it's x is equal to 20 over cosine of 58 degrees. Whew. Okay, so now what you can do to solve this is put this in your calculator and type in 20, type in 20, push the division symbol, and then you push cosine of 58 degrees and close your parenthesis and push enter.
What do you want? Do you want it to be to the nearest tenth, hundredth?
Let's go to the nearest tenth on this one because nearest tenth of the foot.
All right.
Don't forget to
10.5.
Do you want us?
10.6.
No.
10.5.
What?
Do you want?
No.
Not.
Yes.
Evan, what'd you get?
37.7.
feet long.
Thank you, Evan.
Wait, what?
Hello?
I said, Evan, what'd you
Oh,
get?
I thought you said what'd you get. I didn't hear the Evan part.
Wait,
Well, we said the same thing, so
I'll
moving
just
on.
say again if I
Okay, did anybody not get that when they plugged it in?
I guess
No,
You're
just
dividing
physical.
20 by 2 times
Yep.
multiplying.
Not sexual.
Okay,
You,
what?
It's really loud.
Oh, you're supposed to divide it? Oh, so you can't read.
Hey, did you get it?
Yeah, you have to divide by cosine.
You guys get it?
Yeah, I did.
Okay. Everybody else get it? Okay. Hey, mathematically, we can also think of it as this. When we get to this point, when we have cosine of 58 degrees, cosine of 58 degrees is equal to 20 over x. If it helps us, we can say, okay, what is cosine of 58 degrees? We can type that into our calculator. And what is cosine of 58 degrees rounded to 4 decimal places? What is cosine of 58 degrees rounded to 4 decimal places?
1.5299.
So you can replace it there. Would this help you do the math better maybe? Maybe, maybe not. If it does, okay. And then you can multiply by x, and then you have 0.5299x is equal to 20. And then divide by 0.5299.
I put like 4 equals 6.
999.
And x is equal to, go ahead and do 20 divided by 0.5299.
I'm gonna take a shot in the dark and say that it is
Wow.
It's still 37.7.
37.7.
Now,
I like that way better.
whenever we do approximations though, we get a little bit off. So that's why we do 4 decimal places, because you'll still get close. Now this way, in the light blue on the right, this is the way we'll get the closest to our exact answer, is not doing these trig functions until the very end. But if it helps you mathematically to do it earlier, you can, but make sure you round to 4 decimal places when you do that.
Why 4?
Because the further out you go, it's more precise.
So why don't we go to 5?
Wait, so
Because that just, at that
Wait,
point,
how
we
did
have
you
to draw the line somewhere, because it's like, why not 10, why not 20, you know? So we just like 4.
How did you get .5299?
You
Yeah.
put cosine of 58 into your calculator.
Oh.
Which one do you recommend for the ACT?
Well, whichever one's faster for you, actually, because ACT is multiple choice, so they're usually going to be far enough apart, or if you do this, it'll be fine. So, whichever one you're faster at. I'm faster at this, so I do that one.
I'm faster.
Ooh. Okay.
Go.
Example 3.
Jacob, do us a favor.
did you hear me?
Example 3, please and thank you.
Noah.
A pilot, voice off guys, voice off please, thank you. A pilot is looking at an airport from her plane. The angle of depression is 29 degrees. Laugh it out, okay. If the plane is at an altitude of 10,000 feet, approximately how far is it from the airport? Anybody have an idea of how we could draw this? Okay, Ian, you want to try drawing it?
Yes, I will.
I drew a killer airplane on my notes though.
Controlling airplanes.
Well, I drew a pilot, so
Pilot.
the pilot's in the plane.
So
Do not make that joke.
wait, pilot is looking at
No,
the
I wasn't
airport.
going there.
So it's looking down.
What did he say? The pilot's just standing in the air.
You're right. He was aiming for the landing strip at the airport.
It's like a rocket. I can't see. This is depressing.
You'll be okay.
Just like the depression. I am in the middle of this depression angle.
I am in all this depression angle.
Fair enough. Oh, that says
I'm not shaking your hand, I'm just crossing my fingers. I gotta go.
I was like, you?
Look at me, son.
Look
If
at
it
Noah.
helps,
Alright, let's
I
continue
would-
on.
It's like she's playing shoe with a butt here.
No, let's just continue drawing.
You're calling them up there.
It's a her, but okay.
is that a lady?
Literally
Don't
says
say
from her plane.
There are only 2 races.
The future Mrs. Tossel is a pilot, everybody.
There's only 2 races. You
Nice
race
cool
in NASCAR.
career. Thanks.
Okay. So the angle of the depression is 29 degrees
Yep.
right here. Because it's looking down. The airport's like right here.
So, when you take an angle of depression or elevation, what's it in reference to? Perfectly horizontal, right? Is this in reference to a perfectly horizontal thing right now?
Yeah.
Is it? Is this horizontal?
No.
Is this horizontal?
Flip it upside down.
Yeah, the triangle should be
So where would the 29 degrees be? Okay, well, let's, can I see that?
Whoa.
So, if we just draw it like this,
Everyone.
so instead of the 29 degrees being here, since this isn't horizontal and this isn't horizontal, what we need to do instead is say, hey, if we have this horizontal line of sight, the pilot's line of sight, this is horizontal now, so what's an angle going down from it? It's right here, isn't it? So this would be our 29 degree angle. That would be our 29 degree
Wait.
angle. Okay, thank you.
What is?
Ian?
Wait.
This, because the angle of depression has to be in respect to a straight horizontal line. So this was horizontal because it's going down. This one horizontal because it's straight vertical. This horizontal because it's the pilot's line of sight. It's her line of sight. Okay?
Mr. Constable.
Yeah.
Where's the airport? Look at
The airport is over here.
John, thank you.
the John Airport.
This is the airport command center.
Tower, yeah.
I don't know about that.
This is the airport tower.
Yeah,
This is the airport command tower.
According to our drawing proportions, that means the command center is like 6,000 feet tall.
Yeah. Picture not drawn to scale. Picture not drawn to scale. Okay. So hey, picture not drawn to scale. Okay. Hey, Jacob. Yeah.
Does that mean we have to use 151 degrees to the inside angle there?
Okay. So that means this angle would be what?
151 degrees.
Okay. Well,
Spicy.
I don't know about that. Why would it be 151?
It'd be 90.
It'll be the.
It'd be
Yeah.
Oh, so it'd be what instead?
It'd
Mine's
be
like flying bird.
61.
Okay, and this is the right angle, right? Because if the pilots, you were going from pilot 10,000 feet straight down, just like any altitude, you measure it perpendicular to the ground. So that means what's this angle here?
29.
29 degrees. So this angle ends up being 29 degrees. Way down here, too. The angle of depression from the pilot to the airport is the same as the angle of elevation from the airport to the pilot.
Yeah, you made it basically.
Wait, but
Okay, Kaylee.
wasn't the angle of depression go like the top of the thing? Because you're up that high to the top of the thing.
It's just looking downward because we're going to the bottom of the airport.
Oh.
Okay, Kaylee.
How did you get the 61 degrees?
So if this angle is 90, this angle from the straight up and down height, 10,000 feet in the air, to her line of sight is going to be a right angle. Because like, what angle would my line of sight if I'm looking straight and to the ground? Not well, yeah, with the height of the angle would be 90 degrees. So same thing here. So this whole thing is 90 degrees.
Oh, okay.
So we took 90 minus 29. Good question. Thanks for asking. Okay. We know this is 10,000 feet. We know this is 29 degrees. This is the right angle. This is 61 degrees. We're trying to figure out how far it is from the airport. So we're trying to figure out this leg right here, right?
Oh.
Drop the mic.
We're trying to figure out how far it is from the airport. We're trying to figure out, when you measure distance, you measure the horizontal distance, because this is the actual distance it is from the airport. And that's the actual distance it is from the airport.
So we're doing like
So
as
do
the
we
crow
roll
flies.
opposite Jason?
Wait, where are we
Yes.
going if we're not participating in the soccer meeting?
It's at 3:35. So
Frick frack out of here.
So anywhere you go after school normally.
Can't figure out that.
Got you there.
I don't know why.
Hey, Josie, say that louder.
We use tangent
Why do you think we use tangent?
because our x is the adjacent and then 10,000 is the opposite.
From 29 degrees?
Yeah.
Yeah, if we use 29 degrees here, x is adjacent, 10,000 is, let me use a different color here. X is adjacent. X is adjacent here.
I knew it.
This is opposite. And so yeah, we would use tangent. Josie, how would we set this up? Tangent of what?
So then it would be 29 parentheses equals the answer.
Okay. So going back to SOHCAHTOA, going back to SOHCAHTOA.
It's like I got this now. Okay, so if it's opposite, it would be the 10,000 over x.
Very good. 10,000 over x. Opposite over adjacent. SOHCAHTOA is going to help us out here. Kaylee.
So, I have a question.
Yes.
So, is the reason why that thingy, the 29 right there, and that thingy right there, the 29 right there, are the same because it's like, alternate interior?
They would be alternate interior angles. Yeah.
Is that why?
So, that's one of the ways why. So one of the ways why is this angle has to be 90 degrees from the height up to the line of sight. Okay. So this is 29. This one has to be 61. This one's 61 and 90. This one has to be 29, so they add up to 180. That's one way, or you can think of it as alternate interior angles, like Kaylee said, as this line of sight and the distance to the airport, or x, are perfectly horizontal both, so they're parallel. So you have two parallel lines cut by a transversal.
How do you get the 10,000 over X? How do you put it over there?
So we said, Josie said actually that hey, since we can deal from 29 degrees, we could say hey, opposite is what we have is 10,000. We need the adjacent. So we choose tangent first of all because we have opposite and adjacent, and then we say okay, tangent of the angle 29 degrees because we always take tangent, sine, cosine of angles is equal to the opposite over the adjacent. Well, the opposite is 10,000. The adjacent is x. 10,000 over x. Does that answer your question, Ian? Baller shot caller. Okay. How would we solve for this one now?
Multiply that x.
Okay, multiply by x. Same first step. What, Riley?
I kind of
So we'll have x tangent of 29 degrees is equal to 10,000. Very good. Divide both sides by tangent of 29 degrees. X is equal to 10,000 over tangent of 29 degrees. And do we want to leave our answer like this? No. We want it to the nearest tenth. How many feet? How far away is it in feet from the airport?
It'd
So you
be
put that in your calculator.
1,800.
Try reading that one again.
18. What? Oh, I didn't see another zero. That's what I got.
18,040 to the nearest tenth of a foot. 0.5. Did everybody get this? Did anybody not get that? And they need help getting their calculator. You did like tangent of 29 and you did
Yeah.
that?
When I got 0.8.
Okay. So as long as you show your work, I'd accept it.
Oh, okay.
As long as you showed your work and you did 4 decimal places. But that's the difference between rounding early and versus later.
So should I just do it the other way?
I mean, this way you'll get a more precise answer.
Should I just do it that way?
Just way more time than you, as long as you show your work. Fine. Okay. What other questions on this one?
I just want to tell me what to do with it.
Yeah, no.
I can remember how they saw.
It's triggering you a bit. Okay. So we're not going to actually do anything with this except for talk about it. We have 3 methods to find missing sides. Our first method is, hey, if we're given 2 sides of the right triangle, 3 ways to find missing sides in a right triangle. If we're given 2 sides, we can use the Pythagorean theorem to find the third. If we're given 1 side and an angle, well, is it a special right triangle? If so, we can do our shortcuts. If it's not a special right triangle, we can use a trig ratio like we just did when you're given a side and an angle to find the second side. And from there, could you find the third side? Yeah, because then you have 2 sides. And you can also use another trig ratio. Well, fun stuff. Okay. There is going to be homework. Right? That's the spirit.
I mean,
Mr. Coffins are actually bed bugs at school.
yes, there was. It was in my journalism class.
We're not done with my class and I don't want no bed bugs.
It wasn't me, it was like 4 girls that were sitting by a wall.
I mean, you're still that class to get out of this class. I was 40 feet away.
No.
Still.
I don't know.
If I find out
And all of you are scared of something this big.
Okay, hey, when's this going to be due, class? Next class, which is Fun Sock Friday.
I'm gonna wear my fun socks tomorrow. Oh, I don't have practice at 6 a.m.
Guess what?
I'll have better socks than you tomorrow.
My mom bought me 5 pairs.
Oh, my mom mommed them. Not just me mommed them. My laundry mommed them.
You can't be an actual mom.
Exactly.
Can I go to Papa's classroom?
Where's that?
I don't know, but I think if she doesn't put me on